Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. Network interface card is where that network cable actually plugs into your system, and it's important because it has a layer 2 address, which we call the media access control address or the MAC address, and that's unique to that specific card. Now the MAC address is a 48-bit value written in hexadecimal, and no other device is going to have the same MAC address. If you aren't familiar with hexadecimal, values can be 0 to 9 or letters A through F, and we end up with basically 16 total possible options. We aren't going to dive deep into hexadecimal right now, but just be aware of it. The first half of a MAC address represents the NIC's manufacturer, and we call that the Organizationally Unique Identifier, or the OUI. No other manufacturer is going to have the same OUI. Now the last 6 digits are unique to that specific NIC, and we call that the device ID. If you want to see your MAC address on your computer, you can type ipconfig/all on Windows. You can do ifconfig on Mac OS, or you can do IP-A on a Linux machine. All right, so to go ahead and show you what this looks like, if we go into a Windows system first, and we go to the Start menu, and we open up a command prompt window, and we type ipconfig/all. That's going to give us all of our layer 2 information here. Now we also see that it does go ahead and give us some IPv4 information as well. But this is our physical address that is for this particular system. All right, now if we go to a Linux system, and this is CentOS, but this is going to work for any Linux operating system, and we need to open up a terminal window. And then if we type IP-A, that's going to give us all the similar kind of information except on a Linux operating system. So you can see it looks a little bit different, but we do still get that layer 2 address, and we also get some IPv4 information as well. Keep in mind that your computer might actually call the MAC address the physical address. 2 terms that you might see referenced are MAC48 and EUI48. Now MAC48 is the numbering namespace that IEEE originally used to form these MAC addresses, because the MAC address is 48 bits long. EUI48 is the current term for the numbering namespace, and it stands for the Extended Unique Identifier. Now, don't get too hung up on these terms outside the exam, because we'll typically just say the MAC address. Now, layer 2 takes the data that's being sent, and it breaks it up into frames, which are containers for a chunk of data. Each layer of the OSI model does something similar with the protocol adding data, which we actually call the PDU, or the Protocol Data Unit. Layer 2's PDU is frames. Now on the screen here, we have a basic representation of what a layer 2 frame looks like. We have the recipient's MAC address, which is the destination. We have the sender's MAC address, which is who's actually sending out that data. We have the type, which indicates what's encapsulated in that actual frame. For example, does it contain IPv4 or IPv6 data? We have the data field, which contains what's encapsulated. Layer 2 doesn't really care about the specifics of the data, and it just sends it. We have the FCS, or the frame check sequence, which uses a type of binary math called cyclic redundancy check, or CRC, that the receiving NIC actually uses to make sure that all the data arrive intact. You can also break down a frame into 3 sections: the header, the payload, and the trailer. Now a single Ethernet network frame can hold up to 1,500 bytes of data. And if it's larger than that, the sender system is going to break down that data in frame-sized chunks, and then it's going to send it. The minimum that a frame can be is 64 bytes. So if that frame isn't big enough, something's going to get added called a pad automatically, and that's going to be added to increase the size to 64 bytes. Once your frames are converted into bits and bytes, they're sent out of the NIC card, and they've got to go to a networking device. Historically, the networking device would be something called a hub, which is basically like a repeater, and that's going to send out data out of all of its ports without using any kind of logic. That means that all systems get a copy of that data, but if the destination MAC address wasn't theirs, they would drop it. Today, we actually use switches, which are capable of using logic, and they can smartly route traffic based on MAC addresses so that only the intended recipient or that destination MAC address actually gets the data. Now you might be sitting there thinking, well, how do we know the destination MAC address? And that's a great question. A lot of times our systems have already communicated with each other, but if they haven't, then your system can actually send out a broadcast message to the broadcast address, which is the layer 2 broadcast address, asking for the MAC address of a specific IP address. And that's what you see on the screen here, that FFFFFFF, that's the broadcast address. All the systems on the network will see that broadcast message and they'll process it, and then the system with the correct IP address is going to respond with its MAC address. Now that we know the destination MAC address, when we send our first frame, it's going to be using a unicast frame, meaning that we're sending it to a specific destination. This one-to-one addressing scheme is called unicast addressing. The data link layer of the OSI model has two primary jobs. The first job is called the logical link control, the LLC, which is the aspect of the NIC talking to the system's operating system, and it handles multiple network protocols and provides flow control. The second job is called the media access control, the MAC, which creates and addresses the frame. This means that the NIC will add its own MAC address and it attaches the destination MAC address to that frame. Additionally, the MAC sublayer adds or checks the FCS, and then once the frames are complete, they're sent through network cabling. Just a reminder that the NIC is most frequently associated with layer 2 of the OSI model, but it does have slight responsibilities for layer 1 because it does send the data onto the network cables.